A very warm good morning to one and all. On behalf of Parul Institute of Pharmacy, Parul University, I welcome you all to today's webinar session, which is going to be delivered by Mr. Drumil Vyas, Senior Manager, Analytical Development Department, Sun Pharmaceutical Industries Limited, that is R&D section of Tandarja, Baroda, to deliver the topic Basics of HPLC method development. Now I take the opportunity to introduce our today's speaker. Mr. Drumil Vyas has been serving as Senior Manager in ADL Department in Sun Pharmaceutical Industries Limited, Vadodara, since May 2002. He worked in Macroid Antibiotic Limited, Padra, from 2001 to 2002. In Sun Pharma, he has vast experience in the field of analytical method development, validation, quality assurance, and quality control. He is having around 19 years of experience in this field and expertise in the method development area. With this brief introduction, I would like to invite Dr. Drumil Vyas for today's talk. Now, the session is yours, sir. I hand over to you.
Thank you, Falgani ma'am. So good morning and namaste to all students, respective teachers and HOD of Parul University. Thanks Parul University for giving me such wonderful opportunity to present webinar for basics of HPLC method development. Without wasting time, let's start as we have to complete our session in 1 hour. Request all of you to write your doubts and we'll discuss at the end. If time doesn't allow us, then you can also send your doubts to my email ID, which I said in the last slide. I will try my level best to clear your all doubts. So let's start. Basics of HPLC method development. So in this webinar, we'll try to focus on the strategy of method development, which type of mobile phase and pH we have to choose, what type of detector we have to select, what type of separation mode is suitable for us, and how to optimize the method development condition. We'll discuss on that. So everyone is having goal in their life, right? Same way, first of all, we have to define the goal for HPLC method development. Also, it is required to know the nature of sample. Our sample is acidic, basic, or neutral. This will help us to select the detector. Also, we can easily choose our mode of separation, buffer, pH, column. Then after selecting all these things, we have to perform preliminary separation, and then after we have to plan the degradation study. Based on the degradation study, we have to optimize the condition, and as per the ICH guideline, after that we have to prove that our method is stability indicating by performing the validation. So now I move to the next slide. What is required to know before starting the development? To know the sample is very, very important. Why? Because from structure of compound, we are able to understand its nature, like if it is acidic or basic or neutral. This will help us to know the pKa, acid dissociation constant. I hope you all are aware with that. PK will help us for pH selection of mobile phase and buffer selection. I have already captured it in different slides, so we will discuss it later. By seeing the structure, we can understand whether compound is UV active or not. Based on this, we can select detector for development. What else is required to know about sample? Its solubility. How it will help? It will help to select the solvent in which compound get dissolved, and we are able to see the peak of that compound in HPLC. If compound is light sensitive, hygroscopic in nature, then we have to be very careful before using such compounds. We have to follow some specific guideline to handle such compounds. Also need to understand what concentration is required to prepare sample. Try to maintain concentration in such way that your compound will not overshoot and give appropriate response. Would like to add more here about how the specification will be finalized for impurities, just for your knowledge. Based on the daily dose, limit of impurities will be identified. Whatever the drugs we are taking, we can't take it more, right? You all know, doctor prescribed us in a limited quantity we have to take, and based on that daily dose, limit of impurities will be identified. It is recommended that impurities should be detected below 30% of the specification limit. Means if the limit of the impurity is 0.15%, then it should be detected up to 0.045%. We can select our sample concentration accordingly, because it is very, very necessary and required to up to that level we have to identify our impurities. So if any doubt will come, you just write your question, and or else you can ask to Falguni ma'am. We'll discuss it later. I'll move to the next slide. In this slide, we'll discuss about the buffer, why it is required. So generally for preparing mobile phase, buffer is used. Buffer will help for reproducible chromatography. How it is helpful for the reproducible chromatography? Buffer will help to resist change in pH, so that analyte and silica will be constantly ionized. Silica, right now I am talking silica, that means whatever the column, HPLC column we are going to use, it is the silica is the inert material of that particular column. Reduce tailing of compound by effectively masking selenols. So if I'll change the slide, if you are able to see what is tailing. So here the first picture, in that the fifth peak, whatever you are able to see, is showing too much tailing, while all the other three, first row 3 peaks are very sharp, and the last 2 peaks are showing tailing. So if this will help for the basic compound, specifically we face this type of problem in the basic compound. So if we use the buffer, it will mask the selenol group which are available in the silica in the HPLC column, and because of that reason we can reduce the tailing of that particular peak. When you are separating acid and base at a time, buffer will help to maintain consistent retention and selectivity. It is also play a role in reproducibility of separation. This slide shows the different buffer and its pH range along with its UV cutoff. It is very, very necessary that we have to know the pH range of each buffer and also its UV cutoff. If we know the UV cutoff of this particular buffer and the solvents which are going to be used for the separation or develop in the HPLC method chromatography, then we can reduce the interference of the solvents and buffer, and we can only see the required peaks. This will definitely help. So here, if you can see, the phosphate buffer is having a very less UV cutoff. Because of that reason, and the range of pH is also, we can select from different pH range. So the pH range is also very wide. So most probably phosphate buffer has been used for the method development activity. The solvent cutoff is the wavelength below which the solvent itself absorbs all the light. I hope you all are aware with the UV cutoff. So when choosing a solvent, be aware of its absorbance cutoff and where the compound under development is thought to absorb. If they are close, choose a different solvent. What we have learned through above all slides of buffer selection, why buffer is required and which buffer is useful for our chromatography. So anyone can tell me if any doubts over here for buffer specifically? So I'll briefly repeat one more time why buffer is required. So the main is to resist change in pH, which resulting into reproducible chromatography. Also help for consistent retentivity and separation. Help to reduce tailing of compound by masking silanol of stationary phase, and solvent selection. Now I'll move one of the most important parameter, and that is pK, and why it is required and what is pK. So I hope all of you are aware what is pK. pK is acid dissociation constant, pH at which equal concentration of the acidic and basic forms of the molecule are present in aqueous solution called pK. Value of the compound. It's a quantitative measure of the strength of an acid in solution. So nowadays it is very easy to know the pK of compound. How we can know? Google Baba ki jai, right? So Google makes our life so easy. Everything is available on one click. If you guys select pH equal to pKa or very near to pKa for your mobile phase, do you know what will happen? Analyte appear as broad or give tailing. We doesn't get sharper peak. So what you have to do? Adjust pH 1 or 2 unit different from the analyte pK. And what will happen if you adjust pH 1 or 2 unit different than analyte pK? 99% of the sample will be in one form. It shifts the equilibrium, resulting in a consistent chromatography. I hope I am able to explain pK impact. So now we are able to know the pK of compound. We are also able to select buffer. So we can easily identify at what pH we have to work. In the coming slide, I would like to discuss about the impact of pH. pH plays a crucial role. Affect retention time of the compound, controlling the reproducibility, resulting in a rugged HPLC method. pH between 1 and 8 will be used for reverse phase chromatography most commonly. I would like to divide it into two range. One is low pH and another is intermediate pH, that is 4 and 8, and low pH is 1 and 4. Different range of pH has a different advantage. Low pH has the advantage of creating an environment in which peak tailing is minimized and method ruggedness is maximized. So it is recommended to use low pH. This slide will explain how we can increase life of our column and what will happen with column at very acidic and basic condition. At very low pH, that is less than 2, the bonded stationary phase will be stripped from the silica support and column will damage. Similar way, if you work at high pH, that is greater than 8, silica of column will dissolve and column will damage. I have covered separate slide to see the impact of pH on column. We'll discuss it later. Now we'll see how pH is affecting on acidic and basic analyte. pH is having dramatic effect on the ionization state of ionizable analyte. And so this must be fixed. How we can fix it? By buffer to maintain the analyte in the desired state. Also, as discussed earlier, if we keep peak pH equals to its pK, what will happen? Analyte will be in the both state, ionized and neutral. So what will happen? Resulting in a poor chromatography. This already we have discussed, right? Now we'll see how pH will impact on acid analytes and basic analytes in acidic and basic environment. So if an acidic analyte is present in an acidic environment, there will be sufficient proton in solution. The acidic analytes will retain its proton and so will be ionized and suppressed properly. Because of that reason, improving retentivity of that particular compound in reverse phase HPLC. So like retain like, if we like someone, then we can't let them go. So accordingly here, the same is happening. If an acidic analyte is present in a more basic environment, there will be insufficient proton in solution. The acidic analyte will dissociate into its conjugate base and become ionized. Because of that reason, the compound is eluting early, so retentivity will decrease. If a basic analyte is present in a more acidic environment, what happens? There will be a sufficient proton in solution and the basic analyte will become protonated and become ionized, reducing retention on RP-HPLC. The same way, if basic analyte is present in a basic environment, as I said, like retain like, here we are getting a more retention time for the required peak. There will be few protons in the solution. The basic analyte will become its ion suppressed and neutral form. So what we can understand from above discussion? Like retain like. So if you want to retain your compound, accordingly you have to adjust your pH. If the compound is basic, if you are going to adjust the pH basic side, then your compound will retain. And if the compound is acidic and if you are going to adjust pH at acidic side, then your compound is going to retain more. So the adjustment of mobile phase pH can be a powerful tool to obtain liquid chromatographic separation. But at the same time, poor control of the pH can be a source of serious problem with preparation. We always have to remember these things. Do not use pH equal to its pK. Neutral and ion suppressed analytes are more nonpolar than ionized analytes and so will have improved retention on nonpolar reverse phase type stationary phase. How mobile phase pH affects your analytes and HPLC column can help you quickly determine the best mobile phase condition for a separation, reducing the amount of time it takes to develop a rugged method. So now we'll move to the column selection. Different type of columns available in market. As you, sorry, you people are not aware, but industries people are very well aware. Lots of vendors are available and lots of different type of columns also available. So how we have to select our column? We have to select our column in such way that column likes our molecule. If our compound is having carbon, we can select stationary phase in which carbon chains are available, like C18, C8, phenyl. This work well if our compound is soluble in polar solvents like acetonitrile, methanol, water. Phenyl type phases can be useful when separating a variety of analytes including aromatic, polycyclic and unsaturated species due to its pi-pi interaction. Amino and cyano column can be used for separating polar organic molecules. Column behavior at high and low pH. In this slide, we'll discuss what will happen with the column if you choose very low pH and if you choose high pH for your method development activity. So the pH of the mobile phase also affects the stability and lifetime of the silica based column. If we adjust pH very low, less than 1, acid hydrolysis of bonded phase silica started from silica surface, resulting in a changes of retention time. At a higher side pH, if you are going to adjust your pH 7 or higher, the major mechanism of degradation is dissolution of the silica in aqueous mobile phase. This table shows very well if you are going to adjust your pH 7, then if you are going to work on the, you have to work with the less column oven temperature. You also have to use the lower buffer salt concentration and always use higher side of organic solvents. This will definitely increase your column life. If you are going to use higher pH with higher temperature, column oven temperature, if you keep high, more than 40 degree, and if you are going to use the buffer concentration also very high, and if you are not using solvents, organic solvents like acetonitrile, methanol more than 30%, then your column will damage soon and its life is very less. The buffer strength and organic modifier have less of an effect at low pH than at high pH. Now we'll move to the selection of the detector. So these type of detectors are available. We have to choose detector based on our requirement. These are the detectors available in market: ultraviolet UV visible detector, refractive index detector, evaporative light scattering detector, fluorescence detector, electrochemical detector, and mass detector. If we know the nature of our analyte potential interference, it is easy for us to select the detector. Also, it is very important that it should give response to all the available compound in the mixture, and also we are able to establish the limit of detection and quantitation. This is very important parameter before choosing the detector. If we are aware with all these things, then it is very easy for us to choose the detector, and our method development will get easy and we can move faster. To select UV detector, The main requirement is analyte must absorb more light than sample matrix at some wavelength. UV detector is widely used as most of the compounds absorbs at low UV. If we want to develop method of analysis, it is recommended to start development with diode array detector, because if compound is unknown, we can able to identify UV maximum easily, and also useful to check the peak purity of compound. It helps us to know any peak is merging with other peak or not. I hope I am audible, because I just think that I'm just speaking and I'm not getting any response from any of your side.
Sir, you are audible. Actually, there is a live streaming. Students are not in this meeting. So
Oh, okay.
yes,
Oh,
they are in the meeting, right? They are on the Facebook and all. Please continue.
okay, 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 ma'am. So UV detector help us to maximize the sensitivity and specificity by choosing right wavelength. As shown in the earlier slide, different solvents have UV cutoff points, and based on that, we can easily identify what UV maxima is suitable for us. Operating below cutoff point will reduce sensitivity and increase baseline noise due to solvent interference. Different functional group, as you all aware, I think, because we always study this type of things in our graduation time. So different functional group is having different UV maxima. It is required to know the UV maxima of functional group so that we can easily identify what maxima is required for our compound and help to initiate method development. So below are some of the example. If your compound is having amine functional group, the maxima will be 195. Accordingly, you have to select your buffer, because if you are going to use such type of buffer which is having a UV cutoff more than 195, if you are using buffer also such type, and if you are using any solvent also with the UV cutoff more than 195, definitely it will give interference and you will not get a good chromatography. Similar way, ethylene has 190 lambda max, ketone 195, ester is having 205, aldehyde is having 210, phenyl is having 202 and 255, while nitro is having 310. Now we'll move for the refractive index detector and not UV detector. UV already we have completed. So now I'll show you about the refractive index detector. RI detector generally used for those compounds which are having weak or no UV absorbance, like alcohol, sugars, saccharides, fatty acid, polymers, etc. How it works? It is monitor difference in the reference refractive index of the sample cell versus the reference cell. It is also depend on concentration. Very less sensitive, response is also very less. It cannot be used if we have to inject our sample with two different mobile phase at a time. The most notable advantages of RI detection are that the technique is non-destructive, enabling downstream analysis, and RI is a concentration dependent bulk property allowing for universal detection, so all compounds with polarizable electron are detectable. Light scattering detector is one of the detector which is used for the higher molecular weight compounds. It is also mass dependent and non-selective detector. Amount of light scattering is related to the molecular mass of the analyte. It is going to be used for with the gradient system, while Ri is not going to be used for the gradient system. Solvent should be volatile for best result. What about fluorescence detector? Analyte must be fluorescent. Otherwise, we are not able to get any response. Excite at one wavelength, measure the emission at a longer wavelength. Up to 1,000 times more sensitive than UV visible detector. Concentration dependent detector. This is very highly depend on the concentration, and almost it is going to be used similar way like UV visible detector. Electrochemical detector. In this, for which compound we are going to use this type of detector? The compound which is going to be oxidized or reduced by an electric current. For this type of compound, we have to use such detector. More sensitive than fluorescence detector. This detector is quite sensitive compared to fluorescence. But typically it is also not selective compared to fluorescence. Not compatible with gradient illusion. Similar way like Ri. We can't use it in a gradient. So now we'll move for the mode of separation selection. How we can select our mode of separation, and that will help us for the method development activity. So by selecting different combination of stationary phase and mobile phase, we can get variety of separation modes, as separation is based on partition equilibrium between stationary phase and mobile phase. Sample solubility will also play a big role to select separation mode. We can start our development only if we know in which solvent our compound is freely soluble. Selection of separation mode is also depend on how many types of different analytes available in our compound. Majority reverse phase chromatography used as a separation mode due to variety of stationary phase available in market, and polar solvent used in mobile phase are also easily available. So 3 types of mode we are discussing here right now: reverse phase, normal phase, and ion exchange. What is the difference in all these 3 modes? In reverse phase chromatography, whatever the mobile phase you are using is polar, while in normal phase it is non-polar. For ion exchange chromatography, you have to use only aqueous buffer, no any solvents required. Stationary phase is less polar for reverse phase chromatography, like C18, C8, phenyl, butyl, and methyl. While for normal phase, it is highly polar stationary phase, silica, like silica, cyano, amino, and a diol column. Ion exchange mode of separation when it is required to use, while our analytes are ionic or potentially ionic. Major distinction between analytes is their hydrophobicity in reverse phase chromatography, while for normal phase chromatography, major distinction between analytes is not their hydrophobicity. For ion exchange chromatography, pH is very critical. The sample should be soluble in water or a polar organic solvent for reverse phase chromatography. For normal phase chromatography, what is required? Samples should be soluble in hydrophobic solvent. Hydrophobic solvent like non-polar solvent, hexane, IPA, such type of solvents will help. Such type of solvents will help to soluble our compound, and we are able to develop the method in normal phase chromatography. For ion exchange chromatography, inorganic cations, anions, organic acids, base, amino acids, nucleotides, catazolamine, peptides, and antibiotics are the example. For that, we can develop a method for ion exchange chromatography. We can develop method through ion exchange chromatography. So why reverse phase is the most popular mode? Reverse phase because many of the analytes are water soluble. Extensive range of stable stationary phase are available in market, which we can use to alter retention and selectivity. Columns which are going to use during RP-HPLC method development have hydrophobic stationary phase, which works well for retention of most of the organic analytes. We can easily change solvent, pH, column, which help us to identify the most effective selectivity. Because of all above reason, RP is the most popular mode. What is the role of chromatography? It's a resolution. Resolve two or more compounds into separate peaks.